Now that we have looked at topologies, the next topic I wanted to look at is the network management models. There are two basic network management models that are available for a local area network. One of those is the peer-to-peer P2P network management model. In a peer-to-peer model, every computer on the network is responsible for its own security and its own management. Basically, each computer is managed as a separate device, and therefore the management is built around individual computers. Normally, this model will be only found on very small networks. In the case of Microsoft operating systems, if you set up a peer-to-peer network, Microsoft will limit the number of peer-to-peer systems on that network to 10 systems. Home groups and workstations and some of the more recent versions of a Windows Professional and Windows operating system actually are designed to make it easier to configure a peer-to-peer network in home environment or very small business environments. When using a small business environment, generally you don't want to have more than 2 or 3 computers in the business if you're going to use a peer-to-peer model. In other words, a home office or some place like that would be a good situation where a peer-to-peer network model may work for you. Most home networks are also a peer-to-peer model because most home networks don't have a server that they set up in their home and connect everything to that. Instead, each computer in the house is set up with its own security and its own username and its own login, and they are all even access the internet or whatever in the house simply by logging on. And so home networks are probably the most common place you will see a peer-to-peer type network management model. This illustration here shows what a peer-to-peer network management model would look like. As you can see, we have a network with 6 computers, and you will notice that there is a little symbol inside each one of those computers. That is the symbol for a policy and security configuration. And as you can see, each computer has its own policy and security configuration. Therefore, each computer is responsible for its own management and management of the resources it may be connected to. The other management model is the client-server network management model. In a client-server configuration, all devices access the resources on the network through a central server. In this case, for the device to get on the network, it needs to connect to the server, and every device on the network that is not the server is called a client. The device or devices that control access to the network and the resources on the network are called servers. Servers can just control access to the network. They can also control access to files, access to printers, and many other things. But any device that actually controls access or something else on the network is a server or some sort. In a client-server network model, the network management is overseen by a central server. All security is located in that central server, and therefore security is built around access to that server. Some of the things that the server controls is access to network resources. The server is also able to control who is allowed to log on the network or who is allowed to authenticate on the network. This diagram here illustrates what a client-server network model would look like. You'll notice we still have 6 computers on the network, but you'll also notice that each one of those workstations or desktop computers doesn't have a security or policy symbol inside it. That's because each computer does not control all security for the network or even for itself. The security is controlled by the domain controller, and this is shown by the symbol for the security policy being located on the domain controller instead of the workstations or the desktops. For any one of the desktops to access the network or any resources on the network, it first has to go to the domain controller and basically get permission or get a list of what it can and cannot do. Once a client is authenticated by the domain controller, then it can gain access to any resources on the network that the domain controller has permitted access to. Next, we want to address 2 common ways that nodes or computers use to access the network directly. In other words, to be able to get onto the network, not necessarily to get resources, but actually access the physical network itself. The 2 ways that we are going to look at are both contention-based network access methods, which were briefly mentioned in a previous video. Basically, in a contention-based network access method, the computers compete for network access. There are 2 types of contention-based access that are commonly used in modern networks. One of those is the carrier sensing media access collision detection access method, also called CSMA/CD. This method is most commonly used by wired Ethernet installations. The other contention method that is commonly used is carrier sensing media access collision avoidance, also called CSMA/CA. This access method is most commonly going to be seen in Wi-Fi networks. A fun fact about Wi-Fi, the term Wi-Fi actually doesn't mean anything specifically. The person who invented Wi-Fi, when asked why he called Wi-Fi, simply said, "I thought it sounded cool, so that's what I called it." Let's go ahead and look at the CSMA/CD contention method first. In the CSMA/CD contention method, basically what happens is each node or computer on the network listens for traffic going by on the network. If it doesn't hear any traffic, then the node releases a packet on the network. However, if two nodes were listening to the network at the same time and neither one of them hear any traffic on the network, they'll both release their packets at the same time. When this happens, the packets hit each other and we will have what is called a collision. The result of a collision is basically when the packets hit each other, they cause a power spike that's then heard by all the nodes on the network. Also, when two packets collide with each other, they destroy the data that was contained in those packets. This diagram illustrates what a collision would look like. Basically what happened is computer 1 and computer 5 both listened to the network and decided to send the packet at the same time. Well, when they did, their packets ended up hitting each other somewhere in the middle of the network, causing the collision. And therefore the data was lost and the collision was heard by all the computers on the network. If a collision doesn't take place, then CSMA/CD considers that the transmission was successful and now the network is freed up for another node to transmit. But when a collision doesn't take place, this is how a CSMA/CD operation would take place. Computer 1 needs to send a packet to computer 3. Therefore, computer 1 will listen to the network. If it doesn't hear any traffic on the network, it will then release its packet onto the network. And the packet will then travel on the network to computer 3. Once the packet gets to computer 3, the other computers will have heard the packet go by and then know that now the route is freed up for them to send their own packets. And so the contention starts all over again. But if a collision does occur, then all the nodes on the network will hear it and they will start their internal clock set to a random number of milliseconds. Once the clock on a specific node or computer runs down to 0, then that particular node or computer will attempt to send a packet again. This diagram here illustrates what happened. A collision took place, and so a timer or a clock on each one of the computers on the network randomly generated a number of milliseconds and set the clock to that number of milliseconds. Now each node has a different number of milliseconds on their clock, and so as each node's clock runs down, they then attempt to send their packets, and this way there is hope that this will avoid any further collisions. The other type of contention method we want to look at is CSMA/CA. The CSMA/CA works very similar to CSMA/CD. The main difference is instead of releasing the packet on the network, when it hears the network is clear, it releases a warning packet on the network. That warning packet basically runs down the network and warns all the other nodes that a packet is about to be transmitted. When the other nodes on the network hear the warning packet, they won't transmit until after they hear the packet go by. Once they hear the data packet go by, they will then attempt to transmit their own warning packet before they transmit their data packet. However, if two warning packets are transmitted at the same time, just like in the previous example where two data packets were transmitted at the same time, again, it will result in a collision, and the collision is handled exactly the same way as with the CSMA/CD method. This diagram here illustrates how a CSMA/CA method works. Computer 1 again wants to send a packet to computer 3, and so computer 1 releases a warning on the network. All the computers on the network hear the warning go by, and so they refrain from trying to transmit a warning packet of their own. Once the warning goes by and everybody has a chance to hear it, Computer 1 will then release its data packet onto the network. The data packet will move down the network to the Computer 3 and will, as each node hear the data packet go by, they will then try to release their own warning packets first, so they have the opportunity to send the next data packet. The next topic I want to discuss is Internet, intranets and extranets. The Internet is a worldwide publicly accessible infrastructure of cables, routers, switches and servers. One thing to keep in mind about the Internet is that the Internet is not the World Wide Web. Many people will use Internet and World Wide Web interchangeably, but in reality, they are not the same thing. The World Wide Web is just a service that runs on top of the Internet. As just alluded to, you can run a wide variety of services on the Internet. Some examples of the services you can run on the Internet are the aforementioned World Wide Web, email, FTP or file transfer protocol, VoIP or voice over IP, streaming video, online gaming, and many other services too numerous to list here. The intranet, on the other hand, is a privately accessible infrastructure of cables, routers, switches, and servers. Generally, intranets are limited to a single company, organization, or group of companies. However, they can also carry a wide variety of services like the Internet. In fact, all the services that you can run on the Internet, you can also run on the intranet. Finally, we have extranets. Extranets, like intranets, are privately accessible infrastructures of cables, routers, switches, and servers. They are also generally owned by one company or organization or group of companies. However, the difference between an extranet and an intranet is that the owner of the extranet will allow others access to the extranet for a fee or a specific purpose. Also, like the Internet and the intranet, you can run a wide variety of services on the extranet. In fact, any services that you can run on the Internet, you can also run on an extranet, just like is the case with the intranet. Some examples of the extranets you may have heard about are the Microsoft Azure and Amazon's AWS networks or Amazon Web Services.